All right, fifth period, precious fifth period. I'm so sorry that I cannot be with you today. I actually have a doctor's appointment that I'm at. So I made you a little video. We're going to work through the last little bit of your hand trig together. So if you will pull out the sheet that we did last time, looks like this. Okay, and then we are going to run through the tangent questions that we didn't quite get to last class. So your tangent questions are on this page right here. Okay, and then for my sub, there'll be a couple places where I'm going to ask you to pause the video. So for right now, if kids need a minute to pull this sheet out, if you don't mind just pausing it, waiting until they're ready. All right. So let's just review that last time we learned with our hand trig. Go ahead and draw yourself a little hand here. Ooh, it's ugly. Okay, just pretend. So your pinky finger is going to be 0. Your next finger here is pi over 6. Then pi over 4. Pi over 3. And then your thumb is going to be pi over 2. Okay, remember that when you are finding a sine, you're counting the fingers below the bent finger. Cosine, you're counting the fingers above. Okay, so we did all that last time. So when you are finding tangent, okay, in pre-cal, you should have learned that tangent is sine. Sorry for that. Sine divided by cosine. So if I'm doing, for example, number 1, I want the tangent of pi 6, then I'm going to find the sine of pi 6 divide by the cosine of pi 6. So let's look at your hand. Find your pi 6th finger. So for me, pi 6 is going to be this one. Hold it down. And then for sine, I want the fingers below the bend. So if I'm looking at my hand, I see that I have one finger below the bend. That means that it's going to be 1 over 2. Now, remember that technically the formula is the square root of your fingers over 2. However, if I have only one finger, then root 1 over 2 and 1/2 are the same, okay? Back to my pi 6 finger, now I want my cosine value. So cosine is going to be the square root of the fingers above over 2. So I have 3 fingers above, so that's root 3 over 2. Okay, from there, if you are dividing a fraction by another fraction, okay, you are going to need to multiply by the reciprocal of that bottom fraction. Now, what I call this in my pre-cal class, and maybe some of your teachers might have used this little acronym as well, is going to be keep, change, flip. And here's what keep, change, flip means. You're going to keep the top fraction as is. So 1/2 is going to stay 1/2. Then you are going to change the division to a multiplication problem. And you are going to flip the denominator. So instead of being root 3 over 2, it's going to be 2 over root 3. So keep, change, flip is another way of saying multiply by the reciprocal. And you're going to do that when you're dividing 2 fractions with each other. So from there, I notice that I have a times 2 on the top. I have a divide 2 on the bottom. That means that those can cross out. Which means that for my final fraction here, I have just a 1 left on top. And I have a root 3 left on bottom. Now, you'll remember that we briefly talked about last time, okay, that square roots on the bottom for the AP test, they don't really care. But for Delta Math, you're going to have to be able to fix it. So let's review how to do that. If there's a square root on the bottom, you're going to repeat that root on bottom and on top. The reason that we do that is that across the bottom, root 3 times itself becomes the square root of 9, which is now perfect, and I'm just gonna have a 3 on the bottom. On the top, I have a 1 root 3, which is gonna be my final answer. Okay, so remember, square roots in the top are fine, you don't need to fix those, but if you get a square root on the bottom, that's where you would need to fix it. Okay, let's run through a couple more examples. Take a look at number 2 for me, please. Okay, number 2 is the tan of pi fourths. So remember, the definition of tangent is sine over cosine. So I'll find the sine of pi fourths, the cosine of pi fourths, and then I'll divide those. So take a look at your hand. We want our pi fourths finger. Pi fourths is this one. Okay, looking at your diagram here, it's your middle finger. So I'm going to fold that down. For sine, I'm going to get root 2 over 2 because I have 2 fingers below the bend. And then for cosine, I'm also going to get root 2 over 2 because I have 2 fingers above the bend. Okay, which kind of makes sense because if it's your middle.
Sorry for interruption, but at this time in our advisory class, we should be handing out our yonder pouches. Teachers, make sure you have the student's initial and.
Seniors, this message is for you. If you need an ACT waiver,
Oh,
please
y'all,
stop
I'm
by
so
the claim
sorry.
office after you get your pouch. And this is for any student at Richardson High School. If you want to retake the ACT exam and you are a senior, please stop by Ms. Clay's office after you get your pouch. All students can have an ACT waiver.
Okay, so I notice I'm dividing 2 fractions. That means I'm going to keep, change, flip. I'm going to keep the top one, root 2 over 2. I'm going to change the division to a multiplication, and I'm going to flip that bottom fraction. So instead of root 2 over 2, it's going to be 2 over root 2. Then from there, I notice that I have some numbers on the top and bottom that are the same. So root 2 and root 2, one's on top, one's on bottom. I'm going to cross those out. Then I notice that if I cross my 2's out, then it's like I don't really have anything left. That's okay, but remember that you're dividing. So if I do 2 divide by 2, okay, they do technically cross out, but they're crossing out to a 1. Okay, because 2 divided by 2 crosses out to 1. All right. Number 3, we got tan pi thirds. And actually, let's skip that one. Let's just go to number 4. So now I want the tan of pi. So I'm going to do the sine of pi divide by the cosine of pi. Now, you may not remember this from last class, but remember that 0 is the x-axis. And so if I want pi, okay, if I want pi, that is halfway across the circle. And so because I'm also on the x-axis, I'm going to use the pinky finger as my reference. Okay, so for pi, because it's on the x-axis, we're going to use the pinky for that. So pinky's here, fold it down. For sine, I'm counting the fingers below the bend. How many fingers are below your bent finger? Well, if it's your pinky, you don't have any fingers below that, so that would be 0. Okay, then for cosine, that would be your fingers above the bend. So I see that I have 1, 2, 3, 4 fingers above the bend, but remember that I can't bend just this one finger down. It's root fingers over 2. So if I have 4 fingers, that's root 4 over 2, but then the square root of 4 is 2 over 2, which is going to give me 1 for cosine. And then 0 divided by 1, think about that for a second. Okay, 0 divided by anything is going to give you 0. Now, you might in your head have been like, wait, I thought you can't divide 0. Remember, the rule is that you can't divide by 0. Okay, 0 over any other number is okay, you're gonna still get 0. But no, you can't divide 0 on the bottom, that's undefined. Okay, so if you want a little way to remember that 0 on top, that's okay, you're gonna get 0, but no, you can't get it on the bottom. Okay, let's get into some of our other positions on the circle. So let's say that we're doing number 5. So I want the tan of 11 pi 6. Well, then I'm gonna do sine over cosine. So my pi 6 finger is this one. My sine is 1 finger on bottom, so that'd be 1/2. Divide by my cosine is going to be 3 fingers on top, so that'd be √3/2. And then I notice I'm going to have to keep change flip. So it'd be 1/2 times 2/√3. Okay, now I could keep going, but can we just notice, oh, look, these are the same, right? I'm going to cross those 2's out. I'm going to get 1/√3. And then I'm going to be like, oh, wait, I got to fix it. √3 top and bottom, just like I did last time. And I'm going to get √3/3. Okay, so just for review, I can use this same answer because if this is a pi 6 and this is a pi 6, okay, we know that the numerical value of the answer should be the same. Okay, the only question is if you're going to end up in the same quadrant or if you're going to end up in a different quadrant. That's where this 11 is going to come in. So if I want pi 6, let's draw our little unit circle coordinate grid here. Halfway across the circle is 1 full pi. So if I'm counting pi over 6, that'd be 6 pi over 6. Okay, but remember, I don't just want 6 pi 6. The question says that I want 11 pi 6. So if it gets me 6 across the top of the circle, then it'll be another 6 across the bottom, which makes it 12 pi over 6. So I go 6 across the top, 6 more across the bottom. But remember, I don't want full 12. I only want 11 over 6. So that would put me here. Then remember, each of your quadrants is labeled with a letter. It's all students take calculus. So if I'm in the C quadrant for cosine, then that means that sine and tangent would both be negative. So remember, it's all for the first quadrant are positive. Then only sine is positive, then only tan is positive, then only cosine is positive. So whatever quadrant you end up in, that letter's trig is going to be the positive. Okay, let's go ahead to number 6. We want tan 7 pi 4ths. Okay, well, pi 4ths is this finger. I'd get √2/√2. And then if I peek ahead, look, I already know the answer is going to come out to be 1. So I can just steal that answer without redoing all the math. But then the question is, what quadrant am I going to end up in if it's not pi 4ths, but it's 7 pi 4th? So halfway across the circle is 1 full pi. So if I'm doing pi over 4, that'd be 4 pi 4ths. And then if I want to get to 7, that means I'm going to have to go across the bottom of the circle. So that'd be 4 across the top, 4 more across the bottom is 8 pi 4ths. But I don't want all 8. I can see here that I only want 7. So then I would back up, that would put me here. Remember your acronym, all students take calculus. Which means that if I'm in the cosine quadrant, then I know my tangent value is negative. All right, take a look at number 7. Okay, this time I want tan of 5 pi 3rds. Now you're probably thinking, ooh, let's go steal that answer. Okay, but haha, we haven't already done it. So we're gonna skip this one because we'll basically end up finding that answer along the way on number 7. Okay, remember tangent is sine over cosine. Pi thirds, I'm looking at my hand here. Okay, pi thirds, 0, pi 6, pi fourths, pi thirds, fold it down. For sine, I have root 3 over 2. And then for cosine, I'm gonna have just one finger on top, which would be 1/2 or 1 over 2. Then remember, we're gonna keep change flip. So keep that top one the same, root 3 over 2. I'm gonna change it to a multiply, and I'm gonna flip 1 over 2 to be 2 over 1. Then I'm gonna notice that my 2's here and here can cross out. And my final answer is root 3 over 1. Okay, which probably you can imagine the divide by 1 isn't really necessary, so let's just make it root 3. Okay, now we need to check that quadrant. So I want tan of 5 pi thirds. The top half of the circle would be 3 pi thirds. Which means that across the bottom of the circle would be 6 pi thirds. So remember, it's 3/3 to get across the top, that's 1 full pi. And then another 3 takes you to 6 pi thirds. Okay, but I only want 5, which means that instead of going the full 6, I would have to back up into here. Okay, which is unfortunately the exact same quadrant as the other 2 examples, but it's all students take calculus, which means that cosine gets the positive, tan gets a negative. Okay, we've got 3 more questions left from this packet. Take a look at number 8. I want the tan of pi halves. So we're gonna do sine over cosine of pi halves. Okay, then look at your little finger diagram. Hopefully you remember that pi halves, that is your thumb. So my thumb is right here, fold it down. For sine, I have 4 fingers, but remember the formula is root 4 over 2. And then I'm like, wait, square root of 4, that's perfect. That's 2 over 2, which reduces to 1. Cosine of pi halves, look back at your thumb. For cosine, I'm looking for fingers above, and I notice that my thumb is the top finger. That means I have 0 fingers above that. Okay, and 1 divided by 0, think about if that's an okay or a no. Okay, if 0 is on the bottom, that means that it's a no, and your answer is undefined. All right, go ahead and turn to the last page. I scribbled these out, but I can still kind of read them. So we're gonna just run through this very last page. You had some tans and some cotans. All right, so number 4 says cotan of 5 pi 6. Let me rewrite it here. Cotan of 5 pi over 6. Okay, so if tangent is sine over cosine, then cotangent is going to be cosine over sine. And then I'm going to put right here, that means that it's tangent flipped. So if I want cotan, that means I want cosine divided by sine. Okay, however, all the rest of the process is identical to what we just did. So if I'm doing cotan of 5 pi 6, I'm going to do cosine over sine. Pi 6 is going to be this finger right here, which means that for cosine, I'm looking for my fingers on top. I see that it's root 3 over 2. Divide by my fingers on bottom would be 1/2. And then I notice that I'm going to have to keep change flip. So √3/2 is gonna be my keep. Change it to a multiply and then flip, the 1/2 is gonna go to a 2/1. Then from there, my 2's can cross out, which is gonna give me √3 as my answer. Now, if it was just pi6, I'd be done. But since it says 5 pi6, I'm gonna have to consider what quadrant I want that to end up in. So draw yourself a little grid here. Okay, across the top half of the circle, if we're doing pi/6, top half would be 6 pi6. But then remember, I only want 5 pi6. So instead of me rotating all 6, I'm gonna back up. That puts me here, which for all students take calculus, that puts me in the S quadrant. And S means that sine would be positive, but cosine and tan would both be negative. So instead of √3 being my final answer, it would really be negative √3. Okay, since I kind of scribbled on number 8, we're gonna skip that one and let's just finish up with, let's do number 11 and 12. So number 11 said tan 0. 12 said cotan 0. So remember that for tangent, it's sine over cosine. But for cotangent, it's cosine over sine. So if I'm on 0, that's my pinky. Pinky is here. Sine are my fingers on the bottom. How many fingers are below your pinky? Okay, hopefully you said it. There are no fingers below your pinky. That means it's a 0. Okay, versus for cosine, all 4 fingers are on top. So that would be √4/2, which is 2/2, which goes to 1. Now notice 11 and 12 are the same thing but flipped. So if sine over cosine is 0/1, cosine over sine is 1/0. Okay, then I want you to identify which of those is okay and which of those is no. It is okay to have 0 on the top. 0 divided by 1 is 0. Versus no, you can't have it on the bottom. That's undefined. Okay. All right, so I know that was kind of a lot. What I'm going to have the substitute do right now, please, is if you'll pause this video and pass out the prerequisite skills challenge. Okay, this handout is on my desk, so if you'll just give every student one and then come back and hit play. All right, so hopefully everybody is looking at their prerequisite skills challenge. What we are going to do, we are not going to finish all of this today, but I am going to run through this first page with you. I'll hit a couple of examples just to kind of get you thinking. And then for the rest of class, you're going to be working with your table, trying to remember whatever you can remember from your previous math classes. First thing we're going to do is run through your function families. Linear, your parent function is y equals x. And y equals x should be a straight line uphill through the origin. So if my origin is here, you want your line to be like that. Now, obviously, your graph doesn't have to look like that for all lines. Okay, for y equals mx plus b, the m adjusts the slope, b adjusts shifting it up or down. Okay, but either way, this is your parent function, is just y equals x. Your domain and your range for this are all real numbers. Okay, or negative infinity to infinity. Okay, but that symbol means all real numbers. And the reason why is that your line points to the left and right forever. That takes care of the domain. And then it points down and up forever, which takes care of the range. Let's go on to your second function, which is the quadratic family. So y equals x squared. And hopefully you remember that y equals x squared is going to be a U shape. So it's going to look like this. Your domain, because you have ends pointed left and right, is going to be all real numbers. However, your range can't be all real numbers, and here's why. You do have ends that are pointed up forever, but it doesn't go down forever. It has a specific point where it turns around. So it's going down, 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 and then right here, it starts going back up. So if this is the lowest point on your graph, then you would say 0 is the lowest. And then for your highest, you would say, well, it does go up forever, so that would be infinity. Then you should also remember from your pre-cal class, okay, that if you do actually get to a point with 0, you're going to bracket that versus infinity, you're going to leave open. Next one is your cubic parent graph, y equals x cubed. And think if you remember what it looks like. It starts at the origin. And then this one does kind of like a little squiggle shape. So you're going to do the right arm bent up and the left arm bent down. So I always call this a squiggle in pre-cal, but obviously that's not like a real math term. Okay, so you have one side going up, one side going down. Domain and range on this are going to be just like a line. Here's why. This end is going down, this end is going up, this end's going to the left, this end's going to the right. So basically that's going to cover all of your possible x's and all of your possible y's. Very similar to a straight line, except it's just more curved. Okay, bottom row. Absolute value is going to be y equals absolute value x. And then think what the shape is. You got it. It's a V. Just like that. Your domain for this guy is going to be all real numbers. And the reason why is because this end is pointed to the left, this end is pointed to the right, and they're going to go on and on and on forever and ever and ever. However, your range can't be all real numbers because it goes down and then goes back up. So it doesn't go down forever and ever and ever. Your lowest point here is going to be 0. Your highest point is going to be infinity. Okay, then also remember that you have to put them in that order. You can't like do infinity then 0. So lowest comes first and then highest comes second. Okay. All right, in the interest of time, because I can only record for like 3 more minutes, we're gonna skip exponential and log, and then I'll cover those when I'm back with you next class. Okay, take a look at your next section here. We want to describe the transformations to the parent function.
Pardon the interruption. Teachers, again, if you have anyone absent, just hang on to those and try to catch them Friday. If that student does not show up to your advisory Friday, we will turn all the extras back into us up front. Also, students, this is just a reminder, as we handed out the under pouches, that the expectation and the policy is in full effect. We should no longer see cell phones, wireless earbuds, iPads, and personal devices. The procedures for that is the same as they were last year. If we see any of those, we'll take them out, turn them into office 2, send a message to your parents that they need to come and pick that up between 4:30 and 5:30. Teachers, again, please do not forget to take attendance each period, including advisory, and let's make this the best day yet. Thank you.
Okay, so if I have a -4 in my parentheses, hopefully you remember that that is gonna shift your graph to the right 4 units. Remember that this number, if it's a minus, you actually are gonna do the opposite. So that's why a -4 moves it actually to the right. Then I have a +3 at the back. That's gonna shift my graph up 3. And then this number in the very front is a vertical stretch or compression. Okay, and you can tell which one it is based on if the number is bigger than 1 or smaller than 1. So if it's a 1/4, that's a vertical compression. Okay, and that comes from your number in the front is 1/4, which is less than 1. Okay, if it was bigger than 1, you would call it a vertical stretch. Okay, that should be enough to get you through that first page. Okay, then here's what I want you to do. I'm gonna just tell you which sections I want you to work on. Okay, I want you to cover factoring, so turn the page. Okay, you may not remember how to do every question, but I'm gonna ask that you try each section. Okay? Then for solving advanced, I'm gonna have you skip these first 2. Go ahead and turn the page. I'm gonna have you try number 14 and 15. Then go ahead and turn the page one more time. And I'm gonna have you do 18 and 19. Then turn the page one more time. I'm not gonna have you do any of this next page, but then on the very back page, you have a section that has trig in it. And I want you to do all of those. Now, if I were you, I would go ahead and do this section first. Because we just covered it over the last 2 days, so it might be kind of fresh on your mind. Okay, but one more time, the questions that you're doing are your trig section. Numbers 18 and 19. 14 and 15. And then you're gonna give factoring a try. And then just the bottom of this page right here, you should be able to do these 2 as well. Okay, then I will see you guys on Monday next week and we'll go over any questions that you guys have. Y'all have a wonderful day.